This video is on section 6.2 on using the normal distribution. So the shaded area in this graph indicates the area to the left of x. This area is represented by the probability of p that x is less than x. We've been talking about this for a while, so it's always to the left of some value. Then if we want to figure out the area to the right, if we were interested in the area that in this picture is in white, we would do 1 minus the area that's shaded blue, okay? Because we know that all of the area under the curve equals 1. So if we can figure out the less than part, if we want the greater than part, we would just take 1 minus the less than part. So we can use Excel to figure out these values. So now we're going to use the normal distribution. And here's the chart that has all the different situations that we're going to encounter. So I think that here is our syntax for the norm dot distribution, DIST formula. X is the value we're looking at. Then we have the mean, the standard deviation, and then again that word true or false, like we saw with the binomial distribution and the exponential distribution. So true are for our less than or greater than problems. The only time we ever use false is when we have an equal to situation. So again, down here, put my face up here, we have all the situations that we're going to encounter. So if the probability that x is equal to some value, that's no shading on our graph, it's just the point. And we use the norm dot distribution formula with our value x, our mean mu, our sigma, and the word false. And I told you before that there is no area at a single point, and this is when Excel uses a different formula than the other true versions, the cumulative version. So it's a little bit different, but it doesn't matter to us. We just use the word false, and then Excel knows to calculate that with that formula. If we're looking for a probability that our random variable is less than some value x, that's the area to the left. Okay, so in this picture, it's what's shaded in blue. And we use the norm.dist formula with x, mu, sigma, and our word true. If we're concerned with the probability that x is greater than some value, that's the area to the right of x. That would be represented by this white area in the graph. And that's when we do 1 minus our normal distribution. Again, x, mu, sigma, and true. If we're looking for the probability that our variable is between two numbers, so x1 and x2, then we would have two values shaded or indicated on the graph, and we would shade in between those two. We'll see an example of that in a minute. And we would do the normal distribution formula twice and subtract the values. So here I have it in one cell. You do the normal distribution formula with your bigger number, x2, mu, sigma, true, minus the distribution for your smaller number, x1, with mu, sigma, and true as well. And then that will calculate the area in between. So let's look at our first example, and it's from the book 6.8. I changed the number a little bit just to make it, I think, a little bit easier to think about to start. But final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. So that's indicated here with our x is a random variable with a normal distribution with a mean of 63 and a standard deviation of 5. And then, so this is what it looks like if we graph it. So here's 63, our mean. Each one of these sections is 1 standard deviation away. So 5 units, 5 units, 5 units to the right, 5 units, 5 units, 5 units to the left. And then if we are interested in the probability that a randomly selected student scores less than 75, and I write on each of these problems, sketch the graph if it helps you, visualize the problem and see what you're looking for. So then that would look like this with all of this blue shaded. So see, 75 is over here, and you can see from the graph it's going to be a big probability because it's almost the whole thing. So I'm going to pop over, look, I've got a bunch of things open, to my Excel sheet. Here's example 6.8. I have the mean and the sigma in here so we don't forget it. And I'm going to type in my normal distribution formula. Again, remember when you start typing it in, you'll have a lot of different options pop up. Make sure you pick the one that is the one you want, okay? So normal distribution with my value of 75, my mean is 63, my standard deviation is 5, and I'm doing a less than problem. So it's going to be the word true. When I hit enter, I get 0.9918. So that's a pretty big probability, 0.99 or 99.18%. So that's what we get. And that makes sense. That tracks here with this image because it's a lot of the graph is shaded in. Okay, I do think it helps if you have the graph to sort of have an understanding. And you can use that standard deviation to put 63 in the middle, and then you go 5 to the right, 5 to the right, you know, and then you'll see where 75 is, and you'll realize that that's a pretty big amount of the graph. So probability that a randomly selected student scores less than 75 is just under 100%, 99.2%. So same situation for our statistics class. Find the probability that a randomly selected student scored more than 65 on the exam. So again, sketch the graph if it helps you visualize the problem. So now we have our line here at 65, and we're shading to the right of our number, okay? And then what we're gonna have to do is calculate the less than value, and we subtract that from 1. So in Excel, greater than 65, our greater than problems are always 1 minus our normal distribution. And again, we use our value 65. Our mean is 63. Our standard deviation is 5. And we use the word true. We get 0.3446. So that's about 34%. And if you look at the graph, you know, that looks to be about a third. So there's a little bit more than a 34% chance that a student will score more than a 65 on this exam. Find the probability that a randomly selected student scored between 60 and 75 on the exam. So here's our graph. 60 is the leftmost line, and then 75 is the rightmost line. So it goes over here to 75. This one's a little bit harder to tell, like what you think like a good estimation of it might be. But this is our between problem. So in Excel, when we do our between problems, I usually do them just in one cell. I type 2 normal distribution formulas, use the bigger number first, 75. They're both going to have a mean of 63, a standard deviation of 5, and use the word true. But now I subtract off the normal distribution. Let's see if I can spell normal. With the smaller number, 60. Again, 63 is my mean, 5 is my standard deviation, use the word true. And if I do it in one cell, you could do it in 2 separate cells and then use this cell to subtract them. But you're going to need to show your Excel formulas and how you got these answers. So I get 0.7175. So as you can see here, I wrote out the 2 individual formulas and then subtracted them. But the probability that a student scored between 60 and 75 on the exam is about a 72% chance. Golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. So we're going to find the probability that a golfer scored less than 65. Here's our basic graph with our mean of 68. 3 is our standard deviation, so each unit here, marking here, is 3 units away. So less than 65, if we drew that, the line's going to be here and shaded in. It's a less than problem, so going back to Excel, we're going to do our normal distribution. 65, 68 is our new mean for this distribution. Our standard deviation is 3 and our word true. So there's about 0.159% probability, or about 16% chance that the golfer scored less than 65. You know, some of them are easier to look at the graph and estimate, but I believe 16%, right? So that is one standard deviation below, and then all that below, and we know that that's, so this would be between 65 and 71 would be 68, right? So this is 68 here, and then that little bit more. So it makes sense that this is 16. Still golf scores. What is the probability that a golfer scored between 66 and 70? This time our graph looks like this. So again, we're looking for the probability between those two values, between 66 and 70. You can do two formulas if you want, and then subtract the values. So if you were going to do that, this would be the probability that x, I should use little x, is less than 66. So that would be my normal distribution. I would use 66 here. My mean is 68. My standard deviation is 3, and I would use the word true. And then x is less than 70 would be the normal distribution formula with 70, my mean of 68, and my standard deviation of 3 in the word true. And then you want to make sure that you do the bigger one minus the smaller one, and you get 0.495, so about a 50% chance. So if we look at our graph, again, it's not always super apparent, but we get about a 50% chance that a golfer is going to score between 66 and 70%. Sorry, 66 and 70 is the golf score. 50% is the probability. So you can do it in one step, or you could do it in two like I did on Excel, and then subtract the values. If you do this, always remember your probabilities are going to be positive. So if you get a negative number, it just means you did the small number minus the big number, and so you just want to switch them. It's always the big number minus the small number. So each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. We're going to assume the standard deviation is 2 pounds. So our notation here, x is a random variable with a normal distribution with a mean of 28 and a standard deviation of 2. So if a household is selected at random, let's find the probability that it's going to generate between 27 and 31 pounds per month and more than 30.2 pounds per month. So here's what our graphs would look like. So this is between 27 and 31, and this is greater than 30.2. So if we pop over to Excel, we do the between. I'm going to do them in one cell here. So 31, comma, my mean is 28. My standard deviation is 2, and I have the word true, minus the normal distribution for 27. My mean is 28. My standard deviation is 2, and the word true. And I get 0.625. Okay, so this is about 62% of my data is in this section. And then for more than 30.2 pounds, remember my greater than problems are always going to be 1 minus the normal distribution. My number is 30.2. My mean is 28. My standard deviation is 2, and I use the word true. So I get 0.136. So the probability of a randomly selected household generating between 27 and 31 pounds of garbage or recycling a month is about 62, a little bit more than 62%. And a randomly selected household generating more than 30.2 pounds of garbage or recycling a month is about 13.5%. So sometimes we need to find our z or x values that correspond to a given area under the normal curve. So we're going to be using the inverse normal distribution. So this situation might arise when we want to specify a guarantee period, such as a given percentage of the total products produced by a company last at least as long as the duration of the guarantee period. We did this before. We did this with our uniform and exponential distributions, where we would find the critical value, often with a percentile involved, like what percent of products last as long as this. So sometimes it's given as percentile, which is really just a percentage or a probability. But when we look up an area and find the corresponding z-value, we're using the inverse normal probability distribution. So we used to have to use big tables for this. It's good to sketch a graph so that you can sort of see where you think that value is going to be. So here's our first example, back to that final exam scores in the statistics class that were normally distributed with a mean of 63 and a standard deviation of 5. We want to find the 90th percentile, the critical value, the score K, that has 90% of the scores below K and 10% of the scores above K. So a picture of this would look like this. We don't know what number that is, okay, but we do know 90% is going to be to the right of 63. So we want to figure out, we know how much area this is, it's 0.9, and we want to figure out what value would give us a probability of 0.9. So with the uniform, we had to do, because the area was a rectangle, we had to do some algebra to figure out what the value was. So here, so like I said, K is called a critical value. We can use our norm.inv formula, where we plug in the probability, the mean, and the standard deviation to get the value that is going to give us the 90% that we're looking for in this example. Okay, so we have the normal dot distribution formula that we've used. Now we're going to use here it goes, the 90th percentile problem, the norm.inv formula. So if you're given a percentile or a probability and you need to find a value, use norm.inv, plug in that probability. I always do it as a decimal, but you can do it as a as a percent. Our mean for this problem was 63 and our standard deviation was 5. You don't have to use the word true or false for the norm.inv formula. Just those three things, probability, mean, and standard deviation. And then when I hit enter, I get the value. This is the score, so 69.4. So 69.4 is the score that 90% of students got up to or below a 69.5. So the top 10% of students got a 69.4 or higher on the exam. 90% got a 69.4 or lower on the exam. So in the United States, the ages of 13 to 55 plus of smartphone users approximately follow a normal distribution with an approximate mean and standard deviation of 36.9 years and 13.9 years respectively. So we're going to determine the probability that a random smartphone user in that age range is exactly 23 years old. So remember, our problems that are exactly problems are equal to problems, and that's the only time we use the word false. So we're also going to determine the probability that a randomly selected smartphone user in that age range is at most 50.8. So that means less than or equal to. And then we're going to find the 80th percentile for this distribution and interpret it in a complete sentence. Okay, so exactly 23 years old. So down here we have our smartphone example. So we're going to use the norm.distribution formula. The X value we're looking for is 23. The mean was 36.9. The standard deviation was 13.9. And remember, this is the only time we use the word false, okay? So this is an exactly, an equal to problem. So we use that word false and we get 0.017. So a little less than 2% chance that a smartphone user in that age range is exactly 23 years old. Now for our at most 50.8 years old, that's again really less than or equal to. But remember, in our continuous distributions, less than or equal to is the same as less than. So we can just do norm.distribution for 50.8 with our mean of 36.9 and our standard deviation of 13.9. This is a less than problem, so we're going to use the word true. And we get about a 0.84 probability or 84% chance that a randomly selected smartphone user in that age range, 13 to 55 plus, is no more than 50.8 years old. And so now our 80th percentile problem. So this is a norm.inv problem. So equals norm.inv. Remember, we're going to turn that percentile into a probability, so 0.8. Again, our mean is 36.9, and our standard deviation is 13.9. So 48.6. So what this means is that 80% of smartphone users are 48.6 years old or younger, which means 20% are 48.6 years old or older. Now, again, we're just looking at smartphone users in this age range of 13 to 55 plus, but of that age range, 80% are 48.6 years old or younger. 2,000 students took an exam. The scores on the exam have an approximate normal distribution with a mean mu of 81 points and a standard deviation of 15 points. So we're going to calculate the first and third quartile scores for this exam. And we're going to find what the middle 50% of exam scores are between what two values. So remember, that's our IQR. So when we find the first and third quartile scores, we'll know the answer to that question. So over here, first quartile, remember what percentage that is? So that's 0.25 or 25%. So norm.distribution. What am I doing? I want to find the value for that percentile. So I need the norm.inv formula. I saw that. I was like, the x. I don't have my x yet. So I need the norm.inv formula, and I'm going to put my probability in. The mean is 81, and the standard deviation is 15. I get out an exam score of 70.8 or 70.9. Third quartile, so remember that is my 75th percentile, so 0.75, mean of 81, standard deviation of 15, and I get a score of 91.1. So the middle 50% of the exam scores are between the first quartile and the third quartile. If you remember, this is my IQR, my interquartile range. So that is sometimes a good numerical statistic of the range of your data, right? Remember, the regular range can sometimes have those outliers, the min and the max value, but the IQR is the middle 50% of your data, and that can tell us a lot about how spread out our data is. So that's the end of the video for 6.2.